Solve number 1 from problem set 12. I first needed to read the question and understand that what I need to do is find the mass of an electron in terms of gigavolts. Well, I know from lesson 1 that the mass of one proton is 9 and 10,938,291 times 10 to the negative 31st kilograms. And from lesson 12, I know that the mass of 1 gigaelectron volt measured in kilograms is 1 in 783 thousandths times 10 to the negative 27th power. Now, the point of what I'm doing is that this mass, the mass of a proton, is very difficult to say. Before I made this video, I practiced saying it so that I would make sure to say it correctly. There are tons of digits, and it's such a tiny, tiny power that it's really hard to say. Now, if I can rewrite the mass of this proton as a gigaelectron volt, what I'm going to get is this number here. That's 511 millionths. That's a lot easier to understand than this crazy number here written in scientific notation. So in order to do this, in order to write the mass of a proton as in gigaelectron volts rather than kilograms, what I need to do is divide, because I see here is the mass of one proton in kilograms, and what I want to do is split it up into masses the size of 1 gigaelectron volt in order to see how many there are. So I'm going to divide this number here by our mass of a gigaelectron volt in kilograms. Now that I understand what operation I'm doing, I just need to carry out the long division, which I know can be difficult. First of all, we need to notice that this is our numerator. This is the number that we're dividing up into pieces this size. So I set it up this way. Now, I need to move my decimal. I need to move my decimal over 3 places so that this is a whole number, 1,783, meaning that I also need to move my decimal here 1, 2, 3 times. And then I'm going to immediately move my decimal up so that I don't forget to do it later. And I say, how many times can 1,783 go into 9? Well, 0 times. How many times can it go into 91? 0. What about 910? 0. What about, how many times can 1,783 go into 9,109? I have to think about it. I'm going to guess maybe 5 times. So let's see. 5 times 3 gives me 15. Carry the 1. 5 times 8 is 40. Plus 1, 41. Carry the 4. 5 times 7 is 35. Plus 4 more is 39. Carry the 3. And 5 times 1 is 5 plus 3 more. I have 8,915. Perfect. I'm going to subtract. I get 4, 9, borrow from here, and I get 194. Okay, can 1,783 go into 194? No, which is why I bring down my 3. Can 1,783 fit into 1,943? Yes, it can, 1 time. So that's easy multiplication. 1 times 1,783 is just 1,783. So I can subtract, borrow 1 from here, 6 and 1. Okay, now let's bring down that 8. How many times can 1,783 fit into 1,608? Well, 0 times, correct? So let's bring down that 2. How many times can 1,783 fit into 1,608? Well, let's see. It can fit in, oops, sorry, how many times can 1,783 fit into 6,000 82. I'm going to guess 9, but I'm not sure. Let's see how this works out. 9 times 3 is 27. Carry the 2. 9 times 8 is 72 plus 2 more, 74. 9 times 7 is 63 plus 7, that's 70. And 9 times 1 is 9 plus 7, 16. I did a horrible job lining this up. Borrow from here. 12 minus 7 is 5, 7 minus 4 is 3, 0 minus 0 is 0, 6 minus 6 is 0, and 1 minus 1 is 0. Okay, let's do one more decimal place, just for fun. We'll bring down our 9. How many times can 1,783 go into 359? 0 times. I'm going to stop. I'm already here to my 10,000th place, and so I feel like that's sufficient. So after my division, I have 5 and 1,090 10,000ths. And then I have my powers of 10 here. I have 10 to the negative 31st divided by 10 to the negative 27th. Well, in order to make that easier to solve, what I'm going to do is get rid of the negative exponents. And I know in order to get rid of a negative exponent and turn my exponents positive, I need to take the reciprocal. So 10 to the negative 31st is going to move down into my denominator. And then 10 to the negative 27th is in my denominator already, so I need to move it to the numerator. So now both of these exponents are positive since I've taken the reciprocal. And now I know how to do this. 10 to the 27th divided by 10 to the 31st. Well, 27 minus 31 is negative 4. So I have 10 to the negative 4th power. See that 27 take away 31? It's going to be less than 0. It's negative 4. All right. Now if I look back to what my question was asking me, it asked me to verify the claim that in terms of giga-electron volts, the mass of an electron is 511 millionths. Well, this here doesn't look the same, does it? Not really. So let's go ahead and multiply this number out to see if I get this here. So let's see. Negative 4th power. Negative 4th. I know that means my number is going to get smaller. This negative exponent here means I'm going to have a small number. It's going to get smaller, not larger, when I multiply by 10 to the negative 4th. So I can move my decimal over 4 places to the left. 1, 2, 3, 4. Right? I fill in these spaces here. So I have my decimal. I have this new number here. If I want to round to this place, this 9 means that my digit here is going to increase. So I have this number here, 511 millionths. Is that the same here? Yes. So what I've just done is I've proven that using the mass of a giga-electron volt in kilograms, we can rewrite the mass of a proton in kilograms as 511 millionths. And just remember that this is written in giga-electron volts, which I believe we write this way. Giga-electron volts. All right.